mechanics. Okay, here you can see three masses, three blocks are connected as shown. Okay, and this is a table where all these three blocks are kept. Okay, where two of the blocks are hanging and one is kept on the table. Okay, and these blocks are A, B, and C. This is A, this is block A, and this is block B, and this is block C, right? This is block C. Now it's given that three blocks A, B, C of masses 6 kg, 10 kg, and 9 kg. So this block of 6 kg, this is of 10 kg, and this is of 9 kg. All of these three blocks are connected with a string, right? And the coefficient of friction between the table and the block is 0.2. So here you can see this block of 10 kg will experience some friction, and that friction, that coefficient of friction given here is equal to 0.2, which is acting between the block and the table, right? Now, the strings connecting the blocks are light and inextensible. That means the strings which are connected through the blocks are light and inextensible. That means they are not stretchable and they have no weight. Right? Now we need to find the acceleration of the system and the tension in the strings. Right? We need to find the acceleration of the system and tension in the strings. So let us say you can see this mass is of 6 kg and this is of 9 kg. So definitely 9 kg is heavier than or more than 6 kg. Definitely this block will move towards downward. C block will move downward like this, right? Let us say this move downward with an acceleration of A. The same acceleration will passes through over here. Since 9 kg mass is going downward, then definitely this 10 kg mass will be moving towards right? And the 6 kg mass will be moving upward with same acceleration A, right? Now this acceleration for the three blocks and the direction you have seen, right? Now let us draw the free body diagram. Okay, you can see when you draw the free body diagram of A on the block A, right, the weight mg, that is 6g, will be acting downward, right? And through this a tension which will be acting upward will be, let us say the tension here is T1. So T1 is here, right? So that tension will be acting over here, T1, right? On this block A of 6 kg, tension T1, weight mg, then what else? Then definitely this block is moving upward, right? Then the force F equal to ma, that is 6a, will be acting over here, right? Now the equation which came from this mass from the free body diagram of block A is, you can see 6a, that this T1 is greater than 6g, right? So we can say that T1 minus 6g is equal to 6a. This will be the equation which will be applicable on the mass A of 6 kg, because T1 will be greater. Why T1 will be greater? Because 9 kg is more and this string is moving from left to right like this, right? So that means T1 minus 6g equal to 6a is one of the equation which is derived. Now just draw the free body diagram of mass C. For mass C, what are the forces acting on it? The forces acting on it is its weight, that is mg. M is 9, so 9g will be acting on it, right? Apart from this is moving downward with an acceleration of a, so we can say that this mf equal to ma, 9a will be acting downward. And if the tension over here into the string is, let us say T2, like this T2, right? then if T2 will be here, then definitely T2 will be acting like this, right? Now, what is the equation which is derived from here? The equation which can be derived from here is that since the mass is moving downward, right? So we can say 9g is greater than T2. So that's why 9g, from 9g T2 will be subtracted, right? This is the main fundamental which we need to understand, right? 9g is greater than T2. So that's why T2 will be subtracted from 9g and we get equal to F equal to ma. That is the net force F equal to ma, right? So 9g minus T2 equal to 9a is one of the equation, right? So let us say this was equation number 1, this is equation number 1, and this is equation number 2. So we have two equations with us. Now just draw the free body diagram of this 10 kg mass. For the 10 kg, so this was for A, this was for C. Now for the B, for the block B, what are the forces acting on the block B? Block B of mass 10 kg. So the weight will be 10g, right? And the normal reaction will be equal to 10g, n equal to 10g, which is equal and opposite to the weight of the body, weight of this block. And since there is a friction which is applied by the table over here, right? So that friction will be, and the block is moving into the right direction, right, with ma. So we can say 10a. So friction will be acting opposite to it, into the reverse direction, F, right? So this F, the friction, is equal to mu times n. So we can say that if this is this block is moving rightward, okay, then here this is connected with this string also, and this T2 tension which is acting on the block C will be acting here into the right hand side, right, because the string is same. So T2 will be acting over here due to mass of 9 kg, block C, and similarly due to block A, the mass of 6 kg, another tension T1 which is acting over here will be acting on the body, right? This will be in this direction, right? Because the from the pulley towards the pulley, both the tension will be existing in both the directions, you can see, right? So T2 and T1 and F, yeah, Kevin. So here you can see, here T1 will be acting into the left, and on the block B, T2 will also be acting over here. So what we can see, 10A, which one is greater? T2 is greater, right? So T2 will, because why T2 is greater? Because this block is moving towards right. Because 9 kg is greater than 6 kg, and the movement is happening like this. Movement is happening like this, right? Since the movement is happening like this, so that's why T2 will subtract the rest of the forces over here. So from T2, F and T1 will be subtracted, right? Minus T1 minus frictional force F is equal to 10A, right? And this F frictional force equal to mu times N, and mu given to you is 0.2, and N is equal to 10g, that is opposite to the weight, right? So put up the value of mu N. So this will be T2 and T1 will be acting as a variable to us, right? Let me squeeze a little small, yeah. So here you can see T2 minus T1 minus mu N. Mu is 0.2. So 0.2 into N. N is equal to 10g. 10g, this weight, right? Into 10 into g is equal to 10a. So let us say this equation is arrived to us, and this equation number 3, right? When you just substitute, multiply 0.2 with 10, it will be 2. So T2 minus T1 minus 2g is equal to 10a. let us say this is equation number 3, right? Now we have Kevin, T2 minus T1 minus 2 equal to 10a. Not only minus 2, Kevin, it will be minus 2 into g, right? You have left this g. You can correct your answer, right? Now from here we can see we have equation number 1. This is equation number 1, right? And this is equation number 2, and this is equation number 3. So you can see here T1 and T2 are in positive and negative direction, negative sign, and here T1 and T2 are in negative and positive sign. Yes, Kevin. So just add equation 1, equation 2, and equation 3. When you add equation 1 and 2 and 3, then LHS will be added to LHS and RHS will be added to RHS. 9G minus T2 is equal to 9A. This is equation number 2, which I put over here. And what is equation number 3? This one. This is equation number 3. That is T2 minus T1 minus 2G is equal to 10A, right? So when you add, LHS will be added together and RHS will be added together. Yeah, Kevin, you can see here T1 and T1 both are positive and negative with an opposite sign. So this T1 will be cancelled out, right? Similarly, here T2 and T2, one is plus T2, one is minus T2 into a LHS. So both will be cancelled out. We have now minus 6G plus 9G minus 2G. That means minus 6G plus 9G minus 2G, right? All this will be added together, right? So 9G minus 2G, 9G minus 6G is 3G, 3G minus 2G is G. And here into the RHS, we have 25A, 25A, right? So, yes, so you can see over here, T1 minus 6G equal to 6A was equation number 1. And equation number 2 was 9G minus T2 equal to 9A. 9G minus T2 equal to 9A. And the equation number 3 was T2 minus T1 minus 2G is equal to 10A. Right? When we added all of these 9, 6, 15 plus 10, 25A was into the RHS, and into the LHS we have minus 6 minus 2 minus 8, and minus 8G will be subtracted from 9G, so it will be only G. You are right, Kevin, we are perfect. So the value of G is only remaining into the LHS, and into the RHS we have 25A. So this will give you G by 25 as the value of A, right? G by 25 as the value of A, and if G is 9.8 meter per second square, divide it by 25 to get the value of A, right? When you divide it by 25, the value will be coming more or less is equal to 0.3 something meter per second square, right? So I'm not going into the calculations. You can do it, my dear friend. You can do it, dear students, right? So here you can see the acceleration is calculated over here. Now the tension into the string is still not calculated. Oh, what to do now? Since we know the value of A, and we have the equations with us. This is the equation. Equation number 3, equation number 2, and equation number 1. So you can see from equation number 1, you can see if you put up the value of A, you get the value of T1, and if in equation number 2, if you put up the value of A, you get the value of T2, right? So let us solve it. Since we have from equation number 1 T1 minus 6G is equal to 6A, right? This was equation number 1, right? This was equation number 1. So from here, put the value of A. T1 minus 6G will be into the LHS, and into the RHS, put the value of A as G by 25. G by 25. This is the value calculated for A, which we have already derived just now, right? So what will happen? T1 is equal to 6G plus 6G by 25. So this will give you 25 into 6, that is 150G plus 6G divided by 25 as the value of T1. This is the tension in the string 1. T1, this one. This is the T1, right? Should I squeeze a little? I think it's visible. Yeah, perfectly fine. So from here you can see the value of A was calculated. Now T1 is 156 G by 25. So you can simply put up the value of G. So it will 156 into 9.8 meter per second square divided by 25. So this much of Newton is the force which will be, or tension which is into the string for T1. So T1 is just for the block attached 6 kg block number A, which is directly connected. The string will be having a tension of T1 which is equal to 156 into 9.8 divided by 25. You can just calculate, you will get the values, right? And from equation number 2, what we get? From equation number 2, we have 9G minus T2 equal to 9A, right? 9G minus T2 is equal to 9A, right? So this will give you 9G minus 9A is equal to T2, right? We have exchanged 9A and T2 from LHS and RHS, right? So 9G minus 9 times A, the value of A which we have calculated over here, you can see that A is calculated as G by 25, right? A is calculated as G by 25. So just put up the value of G by 25 for this A, right? And we get the value of T2, right? So when you take 9G as common, right? 25 minus 1, 24 by 25 will be left is equal to T2. So 9 for 36, 216 by 25 into 9.8, the value of G. This much of Newton is the value of T2, right? This much of Newton is the value of T2. T2, that means this here, this one. Strain the tension into the string which is just connected with block C, right? So Kevin, you have perfectly correct calculated it. G by 25 is the right answer for the acceleration, and the T1 is 156 into G by 25, right? Just calculate these values, and T2 is 216 by 25G, right? T2 is nothing but 216G by 25. This much of Newton, right? This much of Newton. So in this way we have solved this question, students. Thank you so much for watching. Take care, be connected. Bye bye, happy learning. I will come up with separate session, live sessions, for clear, bringing the concepts very clearly and to entertain your doubts during the live session. Thank you so much. Be connected. Bye bye.